Small satellites like CubeSat and nanosat are one of the fastest emerging technologies in the space sector today. The popularity it has gained in the last few years is remarkable. The guest we have today has been working with students of different universities to launch 75 satellites on this 15th of August. So, on the behalf of AstroCapsule, I, Prasad Doke, welcome you all to the next episode of the Aerospace and Aviation Show. In this episode, we'll be meeting the founding director and COO of TSC Technologies Private Limited Bengaluru, Mr. Sanketh Huddar, sir. Stay with us till the end for a brief discussion on this fastest emerging technology, small satellites.
Sanketh, sir, first of all, a very welcome to the Aerospace and Aviation Show. And without wasting the time, I'll directly go on to questions. So my first question is, any person who is related to aerospace or aviation knows what a satellite is. But the terms like CubeSat, nanosat, and cansat are a bit new. So I want you to let people know what is that, so that the further interview goes properly.
So, okay, that's a very valid question because even when we interact with a lot of students and which we do a lot of, the students are not aware of these new terms called cansats or cubesats and nanosatellites. And so just I'll simplify things for you. Now, for example, let's start with a simple example that is a mobile phone. So earlier days we had huge bulky phones, right? But
Right.
these days it's getting slim and slimmer and slimmer and with much better capabilities and power. So same way, satellites were big, conventional in size, so around 650 to 800 kgs earlier. But now things are becoming smaller and smaller day by day, and same applies to the satellite too. So as part of the new space era, something called this new terms such as the nanosatellites and cubesats have been evolved. So just to show you an example, this is an example of a CubeSat. So basically, the shape of the satellite will be a cube, and the measurement, the standards are it's measured. It's measured as 1U, 2U, 3U, 4U, 6U, 12U, 24U, etc. So the U stands for 1U is basically nothing but 10 by 10 by 10 centimeter.
Oh,
So it's a very small device. This is 1:1 scale. So one U satellite is going to look exactly this big. So what you can do is 2U will be nothing. I mean, it will be nothing but stacking of two 1Us together, on one on top of each other. And same with 3U, and then you have both horizontal as well as vertical stacking. So that's more or less about the CubeSats. Nanosatellites is something that is less than 10 kgs in weight.
oh,
So all the CubeSats are part of the nanosat, and but it's not necessarily the vice versa. Nanosatellites, it just means that small satellites which are less than 10 kg in weight in general. And apart from that, we do have something called as a cansat, and this cansat is nothing but a simulation of an actual working satellite. So you have all the subsystems from an actual satellite, that is your OBC, EPS, your comms, your antenna, all of that is already there in the CANSAT, but it will be a miniature small version without major. It's not meant for space grade components, or it's not meant to survive in space, but for you to test and start off with the satellite development, that you can move with the CANSAT, and CANSATs can they're either launched by a rocket, sounding rocket, or a hot air balloon, or even a drone. So the flight of what it does is you take it to a certain height, that is roughly around 400 or 500 meters of maximum height, and then drop it. So it'll be a free fall, and during the free fall you can collect all the data. So
oh,
that is something. So it's you start with the CANSAT and then move to your actual satellite. So that gives you a clear picture of building a satellite and the process that goes within it.
okay, that's great. But so the TSC Labs, TSC Tech Labs has been a great part of your life now. So what would you like to tell about that?
Okay, so TC Tech Labs, yes, that has been quite a journey. because this was something which we started during our engineering during graduation, undergraduation actually. So and we did work a lot on the satellites per se, but it was nothing. We didn't have a long-term vision at that point of time. And we had multiple prototypes of cansats, around 15, 20 versions, and 5 patents which were published too. And we did multiple engineering models of 1U, 3Us, all different kind of satellites. And that was there, but during the COVID time, that is just before the COVID actually, Feb 2020, we thought of okay, we have the technical knowledge capabilities, let's form it as an organization and try to contribute to the world, to the space domain especially. And that's how we registered our company, and within the first 1 year we did launch 3 satellites. That was during the COVID phase, which was the whole satellite was built, designed, and tested and launched. So that gave us a very, very huge morale boost to us. And currently we are part of the main core technical team of the 75 student satellite mission too. So it's been quite a journey, and a team of roughly around 10 members. And but though the number is small, the amount of productivity is quite large. And apart from that, we do have a lot of ex-ISRO eminent scientists who are with us full time actually, and this comes sit in our office the whole day and guide us, and they do their contribution. And and we do have a lot of networking too. So we may do a lot of networking, and we've collaborated with various space agencies as well as private organizations throughout the globe. So around 8 to 10 different organizations, we work together with them. So it's been quite a journey, and that's something we're really proud of actually.
Amazing. The 75 satellite mission. I want you to introduce us to that too.
Okay. So I think we're all aware of 75 Azadi Ka Amrit Mahotsav, that is celebrating 75 years of Indian independence, and which will be August 15th of this year. So to celebrate that, there are a lot of programs and events that have been put up, missions that have been put up in various domains. But since we have space domain, okay, we thought why not build and launch 75 different satellites and to celebrate the same 75 years of Indian independence. But during that process, what happened was, okay, we thought we can build the 75 satellites and make a constellation, but something that really is lacking in India as of now, more than building and launching satellites, is the ecosystem does not exist. In India, it's if you look at the number of satellites which have been launched apart from ISRO, the number is very small. And even bring it down even to a lower level, talking about the academic institutions that is built by students, we had only 9 satellites, right?
Oh.
Plus another 3 which was launched from our side in the last year, which makes a total count as 12. So that is it just barely reached double digits. But the same thing, you look at the western part, there you talk about Europe or Israel or US, you have thousands of student-built satellites. So we see a lot of development in all the other domains, but satellite ecosystem is being lacking in India. So we thought, okay, let's bring on the institutions, let's collaborate, work with the students from 75 different institutions, and build 75 different satellites, which works as a constellation, but the secondary payload will be different for all of them. So every satellite has its own purpose, and also there will be a constellation, and along with that, 75 different ground stations will be set up at their institution site. So this kind of when you do this in large numbers, that is where we start creating an ecosystem. You start creating that hype towards the satellite for the students.
Right.
So that is something we wanted to achieve, and that has been going beautifully actually. With the number of requests and the interest shown by both institutions and faculty and the students has been amazing. So students want to learn more about the satellite, and especially one other major point that adds on to this is privatization of Indian space sector has, it's in the transition now. So we can contribute to the space domain. We can launch rockets, we can build satellites, we can send out constellations of satellites, and the number of problem statements that you can solve using these satellites, which is small satellites I'm talking about only, it's a lot of applications. I mean, you can literally, even like for a simple example, the best example I like to give is, there's a lot of water leakage underground, but it's easier to detect a water leakage from space than ground itself. So I think that shows a lot. There are a lot of applications which can be achieved, and that is what we're targeting. We're bringing out the best from a lot of different universities. Bringing the best minds together, working on a payload, and coming up with various solutions for different problem statements. And of course, to celebrate our 75 years of Indian independence, no doubt there.
Right.
So that's no more or less about the certified student satellite mission.
Wow. Congratulations on that, first of all. Next, a question I have is, you told that you started TSC while you were in engineering itself, but we found that you are a computer science student. So from computer science to satellites, how did that happen?
Okay, so there is, everyone has some kind of a well-wisher or mentor in their lives. So we had something like that. So that was basically our dean of research and development during our tenure at the lab undergraduation. So his name is Dr. K. Gopalakrishnan, and he is the one who kind of formed this team together. But we did not work on the satellites directly. There were a lot of other projects we worked on. We talk about 3D concrete printer or a food computer, and a lot of agriculture-based solutions, machine learning, AI. So what he basically did was he guided us. He did not move us to one domain, but he showed the verticals. We did not spend our time in the four walls during our undergraduation. We were always outside the classroom. So that's something every student would want to do, but make the best use of it. That's what I would like to say. So we were out of the classroom, and we were working from his cabin every day. So though we used to reach college by 9 a.m., we used to head back home only around 1 or 2 a.m. in the night again. So that's the amount of time we used to spend there, and there was a little funding support, which causes a lot of issue while coming to this. But since the network was already there, that's all through Dr. K. Gopalakrishna's network, and through that we did a couple of internships, and our team was at IIT Kanpur for a while, for like a couple of months, and two projects were sponsored through there. We did our research there, and so on, a lot of domains we did explore, a lot of hackathons we took part in. We won the first place, not only in India but also talking about international hackathons physically at Europe. That is mainly one was at Amsterdam and one was at Tokyo. So all of that kind of experience. Once you move to that, once you have seen that kind of life where it's all not just books, that is something really interesting. And then one day it was this whole thing about privatization and all the talks had started, and everyone knew space domain is one of the next biggest economic market. And so he came up and he was like, okay, why don't we work something related to the satellite? And that initially, the day one when we heard that, we're like, okay, what's satellite or ego domain? But then I would take that words back, and that has been from that day, we started working on it. And talking about me being a computer science student, it's satellite is one project which is truly interdisciplinary. So I'm talking about every domain has a role there. We talk about mechanical, talk about electricals, electronics, computer science, aerospace. All the departments have a role. So that is something. And since I was with a team, we had students from all the departments put together. So since I'm a computer science student, my contribution was mainly towards the software programming and the OS of the satellite, the ground station. So all of this was major things which I could contribute to. And Same goes to the other departments too. Electronic students were able to design the PCBs and design the satellites, all of that, and the mechanical students were able to contribute towards the structure because every single element in a satellite, a lot of thinking, a lot of I think experience, a lot of research work goes into it because that is something which once you send it to space, there's no going back.
Right.
Anything on the ground can be fixed, but what about a satellite? You make one mistake, it's gone. So you'll have to spend the whole money again, build it again, and send it via rocket again. So I think it wasn't a difficult transition. See, we always use the phrase, it's not rocket science. It's easy, you can do it. But rocket science also, it's not. I'm not saying it's difficult, but it's just that with the right amount of experience and learning exposure, it's easy to get into this domain and contribute a lot.
So you told that you had launched 3 satellites in the starting year itself. So how was the experience of making that satellites and what were that satellites for?
Okay. So talking about the 3 satellites, we named it UnitySat, and it was a consortium of 3 different universities. One was SIT from Coimbatore, the other was GHRC from Nagpur, and the last one was JID from Chennai. So these 3 colleges we did identify, and we pitched it to them because we didn't have the funds, and we pitched it to them that we'll jointly build 3 different satellites, the size of 0.3 U. So together, all the 3 will make a complete 1 U. But note that all the 3 are individual satellites. So the colleges readily accepted, and that is something which went very well. And we started designing of the satellite. Now we just started designing, and it was a peak COVID period, and also 99% of the design was done sitting at our homes. Now again, satellite designing is done on generic tools like your KiCad or Fusion 360, Autodesk, all these kind of tools. So that is something which you can directly install on your computer and start designing it. So we took our time, couple of months, doing the enough required research work and past experiences of various students and people who have built nano satellites and cubesats. A lot of research papers. We had to go through it and spend adequate time on it, and then we started the design. And I think it was we used the phrase the fastest built satellite actually, fastest built CubeSat, because it was done in a time frame of around 6 to 7 months, and that's very less for the satellite. And but that's the first part. The second part comes into where fabrication. We found again, when just to add a quick note here, the fabrication, testing, and all this of the satellites has to be done only at ISRO approved centers. So we were not aware of that. So we thought, okay, let's experiment with 3D printing or that, this, and all. But all of those things changed, and we went to the ISRO approved, fabrication facilities, got our satellite, ready. Then we finished the testing, and Feb 24th we did launch our, Feb 28th, sorry, we did launch 3 satellites for the PSLV C-51 mission. And, it was a great achievement, and mainly because of the costing and the time period. If you look at the 9 satellites which are launched earlier, we're talking about the expenditure was around the maximum went around I think 12 crores. That's a huge amount, and the minimum was roughly around at least 3 or 4 crores. The satellite which we designed, and by the way, it did work. It was successfully, it did transfer all the data, and the cost was put together. All the 3 satellites was roughly around less than 1 crore. So that was our biggest takeaway there, objective, and 6 months time period you can build a satellite. What's better than that? And the whole primary mission of the satellite was, see, now for any startup in, think about any other domain, they can easily enter the market. But space domain, until you build and launch a satellite, you cannot enter the domain. You need to prove your space heritage. So that was the primary mission. And apart from that, we also did try something as an intercommunication between the 3 satellites. which is basically nothing but making a constellation, small constellation. And since it worked, the same technology is being applied to the 75 satellites. So that was just a brief about the UnitySat.
So making, designing, and manufacturing a satellite is a different thing, and launching it is a very different thing. So how did you went into that? Because I just saw that you also started launching the satellites yourself.
Okay, so see, there are a couple of things. So yeah, we would always divide it into. There are two phases, major. That is, one is designing the satellite. Second is the launching. When you talk about launching, it's not as easy as taking the satellite, putting it in a rocket. There are multiple parameters, approvals, you need to take from not only national but international levels. So for the frequency, what you use to communicate to your satellite, you need approval from an agency called InSpace, which is an ISRO wing, and ITU, IARU. So all these, ITU and IARU are international agencies. So they need to approve your frequency usage. So once that is done, your satellite registration has to be done, both in InSpace and ITU, IARU. That is because there are many scenarios where satellites can cause damage to other satellites or other bigger satellites. So that is something they should know who should be held accountable. So there are a lot of rules and space rules and laws, and you violate them, there are a lot of fines also too. And in case you damage someone else's much bigger satellite, then that's probably you'll be running around the international court, all the a lot of you'll be probably might end up in jail also. So that was what we heard, and okay, we try to understand about this part because we never focused on the second half. We were only focused on the first half. So then we did understand, and apart from that, we also need something called a deployer. So the satellite directly like this, it cannot go into a rocket. So there is an outer shell, which is again made of aluminium or a metal itself. And all the antennas shouldn't be deployed. It has to be folded. It has to be inside the satellite. And that satellite has to be put into a deployer, which is basically a box. That box is put into a pod inside the rocket. So once the rocket reaches the right altitude, the deployer only opens. The one side of the deployer cap opens and the satellite is pushed out. So these were a lot of things which we had to learn over time, and deployer is something we did order it from a particular agency because it was last minute, and their deployer failed to pass the test on ground. And finally, okay, so came to our rescue. They told, okay, we'll give you a deployer, but a lot of last minute changes to the structure had to be done because not all deployers are same, exactly same. The standards are being set, but when you talk about the minute changes, so that varies a lot. So we had to make last minute changes, and it was accommodated, and we did push through the launch.
Nice. Next question is the startup of the year in IIT Kanpur. How was that experience?
Okay, so I told you, IIT Kanpur, we had a long working relationship, so they were, I wouldn't say monitoring, but they were aware of all the progress we, our team. It was not TAC then. Our team has been, was been doing right from our, I think second year of engineering, and since they were really, close to us and they were aware of everything, it was not only space domain but various domain. We made a lot of contributions, and whatever hackathons also we won. I told earlier that the solutions were implemented actually. So it was all international organizations, and they took our solutions implemented in the villages especially because it was one of our solution was based on the rural area development. So all this they were aware of it, and once we launched the three satellites within such a short time frame, so that has something really caught their attention, and they did award us with the best. It was again aerospace startup of the year, and that has been was really motivational because being one thing every student in India aspires is to be part of IITs and NITs, but being coming from a third tier three college, in Bangalore, and getting an award from one of the top IITs in the nation. So that was really, motivational and felt a little proud, no doubt there, and that pushed us into, getting into the depth of this satellite and space domain.
Amazing. Congratulations on that too.
Thank you.
Next we'll go to the relation with Indian Embassy in Serbia and Portugal. What is that and how is that going on?
Okay, so there's a short story regarding it. So especially regarding Serbia. So I'll just quickly cover that. So one of the cansat competitions. This is a very common throughout the globe, and NASA also conducts, European Space Agency conducts, and the same way there's a small professional body in Serbia called Committee for Space Development (CSPD) Serbia, and they did conduct an international cansat rocketry competition. And okay, we got the invite, and we're like, okay, since we're already working on cansats, why not test it there? And we were like, okay, fine. So we went with I think three to four teams, and we visited Serbia and we took part in the competition, and we bagged the first and second place. And so that's when we met the head of CSPD, and after interactions with him, he was really excited and happy to talk to us, and especially after seeing our old designs on the CAD he was really amazed. And further, after interactions with him, we did understand that there is no space agency in Serbia. So Serbia has never launched any satellites. So it was a little shocking because we were not seriously not aware of this, because a country who's conducting international CANSAT competitions does not have a space agency. So it was this professional body's interest to bring the space domain to their country. So that's when the relationship started, and post that the whole team was called over to India. We signed an MOU, and we did visit a lot of conferences, presented together, and just last year, our couple of members from our team were at Serbia, and the Serbian Indian embassy at Serbia did invite us over, and so then the Serbian embassy also got involved there, and talks are going on to help establish their first, their not first, but their space agency, the nation. And, starting from there, launched Serbia's first satellite, and so on. Same story, similar story for Portugal too. We did meet when we were at Samara University in Russia. It was a small summer school, and we did come across to a couple of folks from Portugal, and those people were already working on a satellite, and again through them we got to know there's no, there is a space agency, but it's very small, and no satellites have been launched. So we thought, okay, why not? We can work together and launch your first satellite too. So currently, I think a couple of the main subsystems, that is their EPS and OBC, we will be providing them. So it will be a joint collaboration, and the nation's first satellite.
Amazing. Apart from this too, is there any future projects of TSC Labs?
Okay, so coming to that, that is always a big question for all startups, right? What happens after this mission? How do we survive? So yeah, so one of the projects which we are in talks, I cannot reveal a lot of details, but we're talking about a huge project that is a constellation of 650 satellites. Again, working towards the education sector itself, and it is, as of now, it's going to be a joint venture, and TSC will be one among the other three companies, and the project man. We don't care about the. We don't take care about the all the logistics and the financing and all the other elements. We are purely technical team, and all we do is deliver the satellites. The project, mission, the whole mission cost has been estimated at around 1 billion USD, and that is something which the finance team is taking care. They're looking for investment, and they've already had a couple of talks with SoftBank too. So anyways, we are not involved in that. We are, as I told, we are only the technical team. So end of the day, if everything goes well, we'll be designing all the 650 satellites.
Okay. So next, I want to skip to the aerospace future or future of aerospace industry in India. Like we have got the IT boom. What I feel is next we are getting the space industry boom. What?
Okay, so that is something I really agree with you. And in fact, what I would say is space industry is going to be much bigger than the IT industry because you look at the estimation, we're talking about trillions of dollars economy and for the globe. And currently, India contributes only 2 to 3% of that $1 trillion economy. And especially in India, we are just starting off. So there are vast opportunities, whether it is reusable launch vehicles or small launch vehicles like what ISRO is trying for the last, I think, 4 or 5 years, which is the SSLV, small vehicles, and apart from that, satellites, and applications based on satellites, whether it is imagery or navigation or even in fact. One of the project we're looking at is providing an SOS emergency to fishermen because once they go into deep sea for fishing, they come back only after 15-20 days. But and there is no network at all, so they'll be in the dark always, and that's the risk they take. And we had a couple of talks with the Tamil Nadu Fishermen's Association, and we're trying to come up with a product and integrate in the same 75 satellites where they have a kind of provision for the people on the land to communicate to the fishermen. So in case there is any emergency or like a tsunami or any emergency at a particular fisherman's home also, they can be pinged immediately and right when the satellite is overhead, they'll be getting a signal. It's a simple beep or a SOS signal. There need not be any message. So the second they see red light blinking, they know something is wrong. So they need to head back to the shore. So that is something which we are doing, and so you talk about the applications. There are a lot of applications, and again we have compiled a book which has around 500 to 600 satellites and different payloads and applications what you can achieve or what you can aim at. So that whole book we have compiled and we call it the compendium of student satellites, and look at only student satellite ideas which have been implemented so far are 600. So we can think about the actual satellites, not as a student, but as a professional body. The kind of problem statements you can achieve or you can solve is immense. A lot of organizations, whether it is your defense or it is your, like I told you, the water supply board to monitor the leakages or oil companies or, in fact, we got a very recent request, if we can build satellites to track gold underground. So it's a mining company, and that is something we're still in talks with. So that also is that is also is a problem statement which can be solved using satellites. So it's literally everywhere, and because of the new space era, the costs have come down. So it's much more. You can. It's not impossible to have these kind of solutions anymore. So you can have a constellation of satellites doing multi-purpose, problem statement solving, and I think it's going to be probably 50 years down the lane. India might be one of the leading country in the space domain sector.
That should be. Next, I want to ask is the education of India. I mean, still the 12th standard. We have very least information about the things related to space sector currently. So, what is your thoughts on that?
Okay, so education in India is still something that has to, there are a lot of changes required, and I think we are lacking a lot there. It's still the book knowledge and less kind of hands-on experiences and experiments that you get. But when you bring in the satellite domain, I think probably like 10% of the institutions in India do offer a course based on satellites. So
Right.
Aerospace is different. I'm talking about satellites. And again, the only subject that is provided, if they do that is, it's only satellite communications. And
Mm-hmm.
even satellite communications, it's a theory subject.
Right.
So that shouldn't be a theory subject. That is something the students should get an experience and that hands-on training to track a satellite, receive data from a satellite, decrypt it, transmit commands. This is something students have to learn and as part of the syllabus.
Right.
So that has been so this is one of the reason we have another set of mission in our company's mission and goals. That is our objective is to create this whole ecosystem right from the academic institutions to professional bodies.
Mm-hmm.
So as part of the 75 student satellite training, mission, we are providing training to at least 200 students from every university. So full-fledged course on satellite, small satellites, design, building, fabrication. We provide an engineering model to the university so that they can touch and feel. They know exactly what or how a satellite looks, and post that communicating with the ground satellite, and also the ground station, full-fledged ground station will be set up in their university, not only to track their own university satellite, but also other open source satellites like you can pick the NOAA weather satellites, so you can receive data from these satellites too. So when you create this kind of whole ecosystem where it's from the end, the start to the end, that is something where the students will show their interest. And again, it depends on the personal interest, no doubt there, but there should be a provision, and that is what we're doing. So we're trying to bring this everywhere, and we have made a 24 to 30 credit complete course on the satellite, and we are providing this to universities, especially autonomous colleges and universities, and asking them to pursue and make a full-fledged course on it. And because the university will have all the equipment and training equipment basically required for as part of that course. So that we're working on it extensively, and so far we have trained almost around I think 3 to 4 thousand students, and that has been, the kind of response we got was immense. And we're also working with other universities to provide whatever the students get trained from us. We want to convert that into credits, which can be transferred during their master's. So some kind of arrangement is being going on, and we're working towards it, so that the training, the student not only feels that they've gained knowledge, but also when you get a certificate that says you have earned 5 credits during a master's, that essentially means during a master's you can skip one subject because you've already earned it. So these kind of benefits also it's very common in other European and especially Russia and European countries. So we want to bring that kind of culture here so that student also gets into more expensive things. Like we have I think from IT we have one this thing, right? I think, not sure of the name, but we do have a portal for extra credits you can earn, and it's like now mandatory for all the college students to take an exam there.
Mm-hmm.
I forgot the name, but okay. So that is something we're trying to achieve, and once you bring this ecosystem into the colleges, the mindset they have is something very different. Because I'm telling you honestly, our team we did sit for the interviews, but none of us. Okay, I got muted. Sorry. So none of the we had a lot of interviews, but none of us ever joined a company. That's a different story, but. When we sat for an interview, our profile, our resume had, projects which are not, as a computer science student, I'll tell you, the most common projects are billing systems, which is
Right.
supermarket, billing system, railways, airlines, or when you tell machine learning or AI, it's going to be the generic projects which are pulled from India. Honestly telling you, because I've seen
Right.
a lot of projects. So when these kind of projects are there in the resume, and the interviewer went through our team's resume and all, the projects were you know satellite based. So
Mm-hmm.
one of them did ask me, personally asked me, and this was an international placement by the way. It was
Oh.
a company from Japan. And I was sitting there. He asked both of them. They asked me, you actually worked on a satellite and built a prototype, Like, yeah, I did with the team, not of course alone, but yeah, we did it. And they're okay, can we see it? So I'm like, okay, sure. And I ran from one building to the other building, got the whole, it comes with a complete rugged suitcase and also. So the case and all, we got it and showed them satellite. They were really impressed. So that is, you see a difference between the normal, projects and these kind of projects. So once, the student gets to feel that, because I felt that personally. Once, you feel special there, you want to move towards that line. No, it need not be satellite or it's not just I'm not talking only about satellite domain, but there are a lot of other domains where you can contribute like this. And when you feel special there, okay, you want to contribute something or do something and achieve something. But that mindset is completely different. So that is what we are encouraging all these students also from all 75 plus universities to do. And apart from that, we're giving them a lot of opportunities where so like exchange programs and summer space schools in various different countries, which are partially sponsored, so that it won't be a burden for students also. So these kind of small changes we're trying to bring in, and though our target is only space domain, and at least it's a start.
Again, I want to get you in the technical section about the space debris. It is one of the major problem in satellite as well as the whole aerospace industry. What are your thoughts on it?
Right. So space debris, yes, there have been a lot of complaints, and it's true actually. Space debris, there's a lot, but see, again, we are just in the starting phases. So people are bringing this up because it is not causing an issue as of now, but at this pace, it is going to be a huge problem. So that is why there is a lot of research going on for the space debris collection also. There are satellites now. I think one Chinese satellite where they kind of put out a net out and from the satellite and they collect all the garbage. That garbage can be launch vehicles or any other satellites parts and all that. So that is really that was really amazing. I mean nobody thought that okay you can just put a net and bring on all the but it's a lot of debris, so it's not possible for one satellite. And there is one other satellite which people are working still not proven, but yeah, they're working with some kind of laser technology where they can burn it up to finer particles. So again, so these are the things there, but that problem does not exist with the new space era because these satellites, small satellites, do not go to higher altitude. They're always in the 300 to 500 or maximum 700 kilometer above the Earth. So that
LEO,
will
we
what
can
happen.
say.
Hmm?
Lower Earth orbit, we can say.
Yes, low Earth orbit it's called LEO, and that is a major advantage because it's closer to the Earth. So what happens? Every satellite it moves closer to the Earth because of the gravitational pull. And based on our simulation, this 1U satellites and all that, in approximately we are targeting 350 kilometers. So 350 kilometers is very close. So we do estimate around a maximum of 7 to 8 years for it to deorbit, and the second it deorbits enters the Earth's atmosphere, it's no more a debris because it completely burns out. So that issue does not arrive with all the small satellites, especially if you're targeting the lower Earth orbit. But the larger Earth, I mean the your geostationary and the higher orbits, that is something still a problem. And there a lot of research has been going on, and that is again a major problem statement given to everyone. It's open to everyone in the group, and that is somewhere a lot of people can contribute their research, and hopefully we come up with better solutions for things. But also one more thing is, if you look at, I think there's a website called What's in Space or What's in Dot Space. You can see the whole pictorial representation of the all these satellites and the space debris and all. Because what there's an agency called NORAD. What they do is it's a US based agency and US space agency itself, a wing of them. They track every single debris. So even a screw is floating around, is tracked. So every single, however small the debris is, it's being tracked. So we know the exact count of it already. And in the picture, when you look at the visualization, it might seem that okay, Earth's space is already filled with junk because you don't see any, blind spots. It's filled everywhere. But in reality, that's something different. Space is very vast. It's a very huge place, and for us to fill the whole of it, it's going to take like probably thousands of years. So we have a lot of time, and it's a really good thing that people have raised early concerns, and we're already working towards a solution even before it becomes a problem. That has been really good, and hopefully even TAC might contribute much on a later stage.
It's a good one. You are involved with various more startups also. So what would you tell about the startup culture in India?
Okay, so startup culture in India is something which we have seen, it grow at a very exponential rate. We have a lot of startups these days compared to the last 5 years, and I mean every year we see at least 5 to 10 startups turning unicorn, and that is something really huge. And since we live in Bangalore, we know the startup culture here. Bangalore is the hub of the startup culture, and there are new policies which is being passed by AICT, the governing body for engineering colleges, to bring the whole startup incubation center and other funding and benefits to the students within the campus. So that is something which is a really good initiative. So people are aware that okay, there are other opportunities for us, or career paths apart from a desk job or working for an MNC. There are alternatives. You can work on multiple things, and there are, because the problems that we have currently are a lot.
Yes.
Currently, we need organizations working towards a solution too. And I'm not talking about only huge MNCs, but yeah, startups need to do that. And a lot of people who we have interacted also, they are more aligned towards the startup culture. It need not be that they have to find, or they have to come up with a solution on their own, or come up with their own startup, but they can contribute to existing startups too. And I mean, we're talking about, we all know, Cred or Paytm, and all these were startups. I think Cred is known for their UI and their ads. Why didn't probably HDFC or ICICI or anyone else think of such kind of a materialistic design UI? That is something which caught a lot of people's attention. And it seems much more easier and simpler to use. And talking about digital currency, that has been, with the introduction of UPI, I think it changed a lot of lives. I mean, India is the only country where people don't carry their wallets anymore. I mean, I don't. I mean, if after you swipe a card, we have it in a mobile phone, and otherwise it's all UPI. So that change is something which it is happening a lot in India, and students are aware of their opportunities, and they know that okay, I need not just go work for an MNC, but I can come up with an idea, a solution, and form a startup with their colleagues, friends, or like-minded people from different universities too. So they're aware of that, and this culture has been growing well, and hopefully a lot more startups. We hope to see turn unicorn and grow over the next few years.
Anything else you want to add in this interview?
So there is, I would say just one thing, because it's a personal point, but I see that it's a common issue for a lot of them. Because during my interview time, I landed the job, the international placement. That is it's called IBJ in Tokyo, Japan, and but it was a very difficult choice for me. I was more inclined towards entrepreneurship startup, because at that point I already had another startup which is GeekSpace Labs, and it's software based, and I didn't want to leave all of that and this whole We had already started working on the satellite, and didn't want to leave all of this and go work in some different country. So it was a very difficult choice. But being coming from a middle class family, everyone has this doubt that okay, probably my job needs to be secure, so I'll go join an MNC. But that need not be the case. Take risks in life, calculated risks online, very much calculated risks, and when you identify a problem statement and you're strong, confident enough that your solution is good enough, then pursue it. Come up with your own startup, solve, contribute to the world. There are a million problems to be solved. Contribute it, and keep this as an option, and do not hesitate to think about the whole middle class family or average income, etc. It's going to take a lot of hustle, day and night, but end of the day, you feel happy about a couple of things. One, of course, it's your company, and second is you're contributing to the world, you're solving a problem, and I think that's good enough, for this. And even if it fails, there's not much to lose, because the first 2 years, you know very well whether your solution is going to work or not, whether your solution is actually a solution, or also to check if the problem statement is worth solving. So once you know these two things, and once you've entered the market and everything is your design is ready, you get it. So you lose a couple of years, but the experience you gain, that's a lot. So any startup experienced, employee is always preferred by the MNCs, because they are aware of the long working hours. They know the problem solving. Their mental ability is something very different, out of the box, not just the bookish knowledge. So that is something. So you lose a couple of years, worst case scenario, but you gain a lot on the other hand. That is outweighs the couple of years. So I think that would be the only thing. Would really love to see a lot of startups to grow right from the academic institutions itself. That's a dream, and let's see. Curious to see how it goes.
Okay. So, and to ending the interview, I want you to suggest a book and a movie to our listeners.
Okay. So when you say book, don't mind, but the only book that pops into my head is there is a book by NASA, which is CubeSat 101. So that is, if anyone wants to build a satellite or get into this domain, that's the first book you need to refer. It has everything. It's a short book, but it holds all the rules, regulations, the laws, CubeSat standards, and introduction to satellite. How do you test it? It doesn't go to depth of technical, but gives an overview of exactly what you need to be aware of to start building a satellite. That is something which we did not go through. That book is something which our team did not go through. So there's a lot of a little bit of confusion midway through the process, but we learned it, and so that is the only book that I would that would come in my head first thing when you ask that question. And apart from that movie, I would say it's always going to be Interstellar. Talks about space, and you know the kind of movie. It's just essentially shows our future. You've already thinking about Mars, and shifting to Mars, and people might start buying lands on Mars already. So these kind of things are involved. I think the movie is very beautiful, and the kind of the theory of the whole black hole and the universe, how they show it, it's really amazing. And I think that would be my favorite. That is the movie I would suggest everyone to watch if they haven't.
Amazing. So, Sanket, sir, thank you very much for being with us. I hope we get with you someday in offline and discuss some more things.
Absolutely. I look forward to meeting you too. You guys are doing a great job, by spreading this, awareness about the whole space domain. Congratulations to you too.
Thank you, sir. Thank you very much.
Thank you.
So that was a beautiful conversation with Mr. Sanketh Huddar sir. If you have any other questions, I'll be mentioning his LinkedIn ID below in the description box, or else you can also comment down your questions and we'll be getting on it. Also, don't forget to like the video and subscribe AstroCapsule for more such interviews. Thank you.